Hello, hello and welcome to this video. So in the last video, we had gone till nth value and we have more example of aggregate functions and window functions, and we will see subqueries as well. So if you have not watched last 4 or 5 videos, you will have trouble understanding this because I'm not going to explain everything which we did from theory because that will make the video very lengthy. So what I suggest you that you uh, go back in the playlist and if you've not watched the videos yet, so go back in the playlist and watch from aggregate functions. That should be 4 videos, I believe. Aggregate functions is one video. Then we have subqueries in another. Uh, Window functions, aggregate functions, window functions, and subqueries. 3 videos and then one of the examples videos. So look at the playlist. Now we will have some aggregate functions with the uh, window functions. So we have average with over. So what we are selecting is department name, employee name, and salary. These tables were created in the previous video, so you need to watch that. And we are partitioning it by department ID. And we are selecting salary, okay? And we select it as the column department average salary, and we are selecting from employees, and we join our department ID of departments and employees table, and order by department name and salary determinant. So let's see this in action. So I have already selected the database and all. So we have the salary by department here, you can see. So engineering is first, marketing, sales, and support, and salary is descending. So you can see that. Next, we have sum as a window function. So we are summing over total amount. Okay, we are selecting sum total amount over order by sale ID and sale date. And we call it running total and order by sale date and sale ID. So we select this and we paste it. So you see 1200 plus 2400, 3600, 45 plus 4500, 8100 plus 1600 is 9700 and so on. You can go on at seeing the same. Then we have total running total per employee. So here we sum over the total amount and partition by employee ID, order by sale date and sale ID. So if you can see the difference here is here there was no partitioning, okay? And here we are partitioning by employee ID. So select this and go on this. So see sale running sale total for employee ID. So 101 did a total sale of 9,000. 103 employee ID did a total sale of 13,000 and so on. Next, we have running average. So we have average, total amount, and partitioning by employee ID. Other things are relatively same. So the link to the SQL script is given in the previous video in the description, and it will be there in the current video's description as well. Now we select running minimum and maximum. So we are selecting employee ID, sale date, total amount, and minimum of total amount partition over employee ID. And then we are doing a max of total amount, and we are calling it running maximum. And minimum is called running minimum. So we select this. There we go. Then we have whole partition aggregation. So we sum total amount over partition by employee ID. So we select this as employee total. So again, you see that the partition is by employee ID. So for each employee, we will have the employee total. Okay. Now we have department sales. So we are selecting department name, sale ID, sale date, total amount. We sum S dot total amount over department ID. So that will give us department sale. And we have two joins here. We say that employee.id is equal to s.employee ID, because now we are involving sales as well, sales and employee. And for department join, we have department ID dot, sorry, department ID and employees department ID. So partitioning is done on department ID, and the selection is from sales because we need the total amount. So we put this, and we have the department total. So engineering has 33,400, marketing has 21,700, and so on. Next, we have window frame, last three rows here. So we select, we have the average over total amount and partition by employee ID, order by sale date and sale ID, rows between two preceding and current row. That will give us three rows. So we have three sale moving average. That's how we do it. Okay. Next, we have previous row through current row. So the key is here, sale ID, rows between one and preceding and current row. So we see this. So there we have 2400, 4800, 3600, and so on. So you see last two rows. So 2400, 2400, 4800, 1200, and 2400 is 3600. Some of it is not covered in theory yet, but the example you can see. Then you have current row through following row, rows between current row and one following. We have not covered the current row between and all those. So this is the current plus next side. So you can look at the example and understand it. Then we have named the window. So we do row number over W as partition. Now what is W is window W as partition by employee ID. So basically you are partitioning by employee ID and we are calling it window W. So row number W as position and use sum total amount over W. So for each employee ID, we'll get only one row. Okay. Did I? Okay. Let me think why we didn't get. No, we won't get one row. Okay. For getting one row, we won't have to do running total kind of query. So we'll have to do some in other ways. Okay. This won't give that. So we'll see that in subqueries how you can do that. Okay. So for example, if you want to get total of employee ID, okay, so you need to do it in a different way. I'll show you that later. Then we have employees in each department. So we select department name, employee name, salary, position from, now this is example of a subquery. Okay. So what we do is, it is not exactly a subquery. It is basically you select certain number of rows and then you query on that. So it is kind of a subtable. So we create a subtable, department name, employee name, salary, and row number over partition by department ID. So we first have department IDs, okay? And this row number will be called position, and we select it from employees. And we join the department's department ID and employees department ID, and we call it RAM, okay? So we have where position is less than equal to 2. So from position from the position less than equal to 2. So this is selected as position. Okay, this is your position. And position should be less than equal to 2. So we select this. So you get only 2 rows from each department. And we see the position which we acquired by calling row number function. Then we have sales for each employee. So we select employee ID, sale date, total amount, and position. And our sub table is we select employee ID, sale date, total amount, row number. Now row number partitioned by employee ID, this is position and this is sales, and this should be ranked. And where position should be less than equal to 2. So this is 2 sales for each employee we will see, just like the previous one. So we are not looking at salary, we are looking at sale. So we have 2 sales from each employee. Okay. Now we continue here and we will look at employee sales compared with the department average. So how do we do this is we take some total amount of employee sales and we compute average of our total amount and we partition it by department ID. Okay. Now we will need join, of course, because we are involving 3 tables. We are selecting this from sales and employee ID of employees and sales employee ID should be same, and department ID of department and employee department ID is same, and we are grouping here by department name, department ID, employee ID, employee name. So that will give us the uh, whole departments stuff together. So let's see this. So we have department average employee sales that is constant for engineering. So if you look at the department average employee sale, how we computed it, we took the sum and we computed average of that. Okay. So that's how we got this. Now we rank employees by total sales. So we compute total amount as total sales and we rank over and we order by total amount as overall rank, and dense rank we compute with partition by department ID and we order by total amount as department rank. Okay, so this will give overall rank and this will give department rank because we are partitioning by department ID. Observe that this is not partition. So it will work over the entire table. And other things are relatively easy, the joins and stuff. So we have this. Okay. So you can go ahead and not go ahead, subqueries have come up. Let me show you subqueries. Okay. So we select employee ID, employee name from employees where exists, select one from sales is where s dot employee ID is equal to e dot employee ID order by employee ID. So what we will have is we will have employees and their name which have done some sale. Okay. So not some sale. Yes, some sale. If an employee ID has not made any sales, we will not have an entry in sales table. Okay. So let's see this in action. And we have all the employee IDs which are made some sales. Okay. Now we have correlated exists. So again, we select employee ID and employee where we select one from sales. So this time total amount should be greater than 4,000. Okay. S dot total amount should be greater than 4,000. Now let me show you sales table a bit because we are not showing any joins here. So we need to look at the structure of the table here just to refresh. So where are the sales? Okay. So total amount is here. Okay. There is one column. Now we need to go to column. Okay. So total amount, if it is greater than 4,000, we will have employees which made a sale greater than that. So remember, we got 14 rows here, and now we got only 3 rows. So only 3 employees made sales greater than 4,000. So this is an example of subquery. Okay. Now we have employees which did not made a sale. So we call not exists here. Right? That is one of the subqueries, and there is no such employee. Then we have exists versus join. So exists returns one an employee once, regardless of how many fields will match. Okay, so for example, total amount greater than 3,000. So as you remember, exists kind of short circuits once it finds error. It will give you only one row all the time. So if you do not follow this, you need to go and watch the theory side of it, where we see the short circuiting of selects. Now we have the in query, which will be probably the most useful stuff. Okay. So first we read the subquery. So what we are selecting is we are selecting distinct E2 dot employee ID. Oh, why this is E2? Okay. E2, what is E2? Oh, employees. Yeah, okay. Same table is referred as E2. So the department ID of the employee should be distinct, and we join it with sales, and total amount in sales should be greater than 4,000. So we are selecting the distinct department IDs where department ID of the employees where the employee has made sales greater than 4,000. So this will give us kind of a table. Okay. Now we look at all the department IDs in that. Okay. So we look at employees, and whichever employee's department ID is part of this subtable, from that subtable we select employee ID and employee name. Okay. So it would be somewhat confusing in the beginning, but essentially it is very easy to understand. Then we have in with a sample subquery. So we select employee ID from sales where total amount is greater than 5,000. And we take all those employees and find their ID and name. Okay. So here you can see this employee ID directly matches sales employee ID. So you can have a join as well. Now in using product subquery, so we had a product table as well. So what we do is we first select all the product IDs whose category is software. And for all those product IDs, we find out which employee did the sales. And from that, we find out what is the ID and name of the employee. The employee ID you can get from here as well, okay? But the name you have to get from the employees table. Let's see this. So those are the employee IDs and name. It made the sale of a software product. Then we are not in. So these are the employees which made the sales whose total amount is less than 5,000. So these are the employees. Now we have not in personal example. So we create a temporary table here. So now we insert into that which are nullable employee IDs, 101 and 102 and null. Okay. Because null exists in the subquery result, not in can produce null rather than true. So what we are doing here is we are selecting employee IDs from this new template table, and we find that this should not be endless. And then we select the employee ID and employee name. So one of the employee IDs here would be null, which would be just 101, 102 and null. You see, you get nothing here because of that null. Okay. But a better way to do from that is you use not exist. Only select from nullable employee ID and do a join on employee ID of employees and this new table employee ID. So this one, you see 101 and 102 did not come, another employee ID is came. Right. Now we have employees whose salary is greater than any salary in the sales department. So here we can compare the salary is greater than any of salary of another employee. So we have these many employees. Next, we have engineers whose salary is lower than at least one engineering employee. So here department ID is specified for that. So we have these many employees whose salary is lower than at least one engineering employee. Any is equivalent to a sum test. So this you can again refer to the previous video where we read the documentation to understand what sum does. And there we go. Then we have a correlated subquery. So we will find employees who salary exceed at least one employee in their own department. So again, you see how the NA is used here. So we have covered this all this theory, and it is just for example. I think I'll stop here and I'll let you execute remaining queries and understand what it does. Okay, it will be very difficult for me to go through the entire one. It will be a very long video. So please go through the gist which I have made for you, and the link will be in description, and go through all these queries. Some are somewhat complex. And if you have questions about this query, for example, this one is quite complicated. It looks like quite complicated, right? So if you have questions about any of these queries, let me know in the comments and I'll be happy to help you. Also, if you want to ask me questions, you should ideally join communica.restaurant.org, and here you can ask questions related to SQL. So if you come here and ask a question, rest assured that I'll answer you. That is if I know. Okay. So some of the queries can be quite daunting to decipher and so on. So please go through this at your leisure and execute all the queries and let me know whether they work or not, although I tested. But if there is an error or if you have a trouble understanding any of these queries, then let me know and I'll be happy to help. So with this, I will end this video here and let's see what do we have left. Pillar slash download first video. So after subqueries, what do we have here? We have row and array comparisons. Okay. So we'll see it should not be a big one. Row and array comparisons only 2 pages. So we'll look at set returning functions as well. Right. So these two we will cover, and so it should be finished within a video, and then we will look at the examples. So once again, watch the theory and then the example. Otherwise, examples won't make sense to you because I normally don't explain the theory in the example. Right? I expect people to know the example. So with that, I'll end this video and we'll meet again tomorrow with another review of PostgreSQL documentation. Till then, stay curious, keep learning, and most importantly, enjoy.